Hi everyone, I am Ken Hong. I am from Practicum H5D3B. Nice to meet you all.
Hi, I'm Kang Shi. I'm from Practicum H5T3A. Nice to meet you.
Hi everyone, I'm Keshika from H5DO3B. Nice to meet y'all.
Hi, I'm Ken Hong. Now let's start discussing about the past year question number 6 in chapter 2. So a drunken motorist who is moving at a constant velocity of 90 km per hour passed a stationary police patrol car. The patrol car immediately gives chase at a constant acceleration and catch up with the motorist after a distance of 10 km. So from this question, we can know that the initial velocity of the motorist is 90 km per hour, and the police patrol car, the initial velocity is 0 because it stay in stationary. So u equals to 0, and this one u equals to 90 km per hour. So here is an extra information about the police patrol car, which is the constant accelerations, and also the distance, which the s equals to 10 km. So before solve this type of questions, we need to change all these figures, 90 km per hour and 10 km to SI unit. So let's change the unit first. 90 km per hour, to change to meter, 90 times 10 power 3 to change to meter, and 1 hour. 1 hour is equal to 60 minutes, while 60 minutes is also equals to 3,600 seconds. So is 1 times 60 times 60 to become second, and you will find the answer 25 meter per second. So the next one, 10 kilometer. To change this to meter, we need to times 1000, and you will get 10,000 meter. So before we start solving this question A, which is the time taken by the patrol car to catch up with the motorist, let's us to refresh back the 4 equations of the linear motion, which is the first one, v equals to u plus at. Second one, v square equals to u square plus 2as. Third one, s equals to 1 over 2 u plus v times t. And the fourth one, s equals to ut plus 1 over 2at squared. Since for this question we don't know the final velocity of the drunken motorist as well as the police patrol car, so we cannot use these 3 equations, and we actually to solve this equation with this equation. So s equals to ut plus 1 over 2at squared. S is equal to 10,000 meter from here, and u is equal to 25 meter per second. T is the thing we need to find, plus 1 over 2 of a. Since the a, here we know that it is a constant velocity, so a is equals to 0 and t squared. So we simplify this equation, 10,000 equals to 25t, and finally t is equal to 400 seconds. For more information, let me show you how to draw the ST graph for this type of question. So we have the y-axis s with the unit meter, as well as the x-axis with the t with the unit of second. So here we need to draw a straight line here. To represent the constant velocity of the drunken motorist in 90 km per hour, as well as the same with the 25 meter per second. So for more information, to determine the velocity from the ST graph, we need to find the gradient of the graph. So this is the ST graph for these questions, and here will be 10,000 meter, and here is we find is the 400 second. So that's all for this question. Okay, let's continue with the next question. Question B. Calculate the acceleration of the petrol car. So we now need to find the acceleration of the petrol car. So since we have the information here, S is equal to 10,000 meter, U is equal to 0 meter per second since the petrol car is initially in stationary, and T is the just now we find one is the 400 second. So we still don't have the variable V, so we just can use the same equation. S is equal to ut plus 1 over 2 at squared to solve this question B. So as we know that this is a 10,000 meter, U is 0, T is the 400 second, plus 1 over 2, A is the thing we need to find, and T is 400 squared. So we simplify this equation, become 10,000 equals to 80,000 A. So we finally get the A. The figure is 0.125 meter per second. For more information, let me show you how to draw the ST graph for this question. So label the y-axis here as with the unit of meter, and also the x-axis T with the unit of S. So here will be 0, and you draw the graph. This is a curved graph upwards, which showing the acceleration increases. So you can see here the gradient is continuously increases, and here will be 10,000 meter, and here will be 400 second for this question. So that's all for these questions. Thank you very much, and now I will pass on to my teammate Kangshi to continue to the next two questions. Thank you.
Hi, I'm Kang Shi, and I'm the one who will continue the lesson. For C, we will have to find the velocity. And when talk about velocity, most of the time, we will use the formula v squared equals to u squared plus 2as. And it's very simple actually. We just substitute the information given in the information we have found in the previous question, which is 0 plus 2a acceleration and s in the standard unit form, which is 10,000 meter, and we will get our answer. And that's it. And for D, we have to draw the graph. Displacement against time. Firstly, we'll label them for the both axes. Then from the previous question, we know that the displacement traveled is 10 kilometer and the time is 400 seconds. So it's quite simple. Then it said both vehicles, which include the drunken motorist and the police car. And we know that the police car has undergo acceleration while the drunken motorist is traveling at constant velocity. So the line will be the line for the motorist will be a straight line, and the curve for the police patrol car. This is the drunken motorist, and this is the police patrol car. And don't forget to write the 0 at the origin, and that's all.